Okay, yes. Hi, I'm back. I know I've been gone for a while, and I'm sorry. But while I was gone, I was building something pretty cool, and I would like to show it to you guys now. What I built, this is my 1999 C5, and it's called the FRC model, which stands for Fixed Roof Corvette, if you don't know. Basically, this was the predecessor to the C5 Z06, and the biggest difference between this and a base model C5 is, of course, fixed roof instead of the target top, and that explains a shorter window. It's a stiffer chassis. It's the lightest C5 available besides C5 Z06s, which are like 50 pounds lighter just from the windows being smaller. Anyways, this now, as you can tell, has a Holley high ram intake sticking out the hood. And there's not much under the hood, which you now have to open very carefully because there's a lot of flex in it now. Someone cut out the supports, but an idiot. But now it's actually has a solid roller custom comp cam that Aaron, Mick, and I developed. We ordered one cam at first, and we knew it was gonna be big, and I mocked it all up. It was too big, so then we reverse engineered a new cam, which is what I'm running now. It has Texas Speed, CNC ported 243 castings, FIC, I think these are the 540 or the 560s. They're actually an LS3 injector, which is the only difference in height. So it's got little spacers that they look pretty cool, little blue FIC logo. What else? So solid roller. It's also running comp cams, BSR shaft mount bolt down rocker system. And if you don't know, a solid roller engine needs valve train lash. Well, LS engines have a bolt down rocker. They don't have an adjustable rocker arm like small block Chevy. And so the only way to run lash is to either do a Jessel system, which is like $1,200, or you can run Comp's Super Trick BSR system. Oh, I'm sorry. Or yeah, so if you want to run the Comp system, which is a bolt down, and it's a lot more affordable than Jessel, you have to then run Comp's adjustable push rod. And I have a couple clips of that, which I will cut to now. So there is the shaft mount rocker assembly, and these are much better than regular because the whole assembly is connected to one steel shaft, so each bolt is supported by all the others when you run heavy spring pressure like this. Next, here's one of those push rods I was telling you about. So check that out. The bottom is 3/8, the top is 5/16. And they pull apart like so. Boom. And then I stack up the shims inside of this to get my valve lash. Pretty trick. All right, confession time. I filmed those probably a month and a half ago. I don't quite remember what I said in them, but I'll cut this out or edit it if I need to. Anyways, it has an adjustable push rod that is a 3/8 lower with a 5/16 upper. The 5/16 upper slides into the 3/8 lower, and you literally have these little itty bitty shim washers that you stack up in between them to adjust your lash. And then you can take those washers and you can lap them down or sand them down to really fine tune the combination. Right now on this engine, I'm running 12 thou intake and 14 thou exhaust hot lash, and the valve train is just super quiet. I'm super happy with the system. It just looks badass. Anyways, I've been running for about a week now, a week and a couple days. Been street tuning it for the most part. I tried E85. I couldn't tell a difference because it is naturally aspirated, of course. but I did tell a difference in the data log where my fuel pressure went from a normal 60 psi to like 35 psi wide open. So that's no bueno. So anyways, I'm back on 93 octane. I'm gonna do a couple highway pulls to check my lambda, make sure everything looks good, make sure my VE table is dialed in. That way when it's Tuesday and I go to the chassis dyno, I don't have to waste a bunch of time smoothing out my fuel curve, and you now have to close the hood twice. One side, two side. There she is. So I'm gonna switch you guys over to the GoPro. We're gonna drive around, get on the highway and do some pulls. Alrighty, let's get this going. Okay, got HV Tuner scanner going. And let's go for a little ride. The torque curve is from like 5 to 7, and so below that it's faster than it was stock, but you can definitely feel when that manifold comes online, and it just feels like a turbo car when it picks up. First gear is non-existent. Holy smokes. Pull over up here, and I want to look at my data log and see how the fuel curve looks based on our target. All right, so make sure y'all can see this. Alright, so it might be difficult for y'all to see, but basically what I'm looking for right now on gasoline, I'm targeting 0.85 lambda. And so what I want to look at is during that pool, where was our air-fuel ratio measured in relation to our target? So it looks like at the very beginning of the pool we were a little rich. I should say under 5,000 RPM we were rich. Actually all the way until about 6,400 we were pretty rich. And then it actually ended up leaning out around 7,000. Okay, yeah, so we're 0.82, 0.82, 0.82, 0.80 0.82, 0.84, and then it leans out 0.89, and then at 7200 it was actually 1.13, but that might have been me and the rev limiter and fuel cut and all that fun stuff. So I'll go back to my volumetric efficiency table. Because I'm not running this car with a mass airflow sensor, I'm just running it in VE mode, which I kind of prefer to do on a combination like this. It just makes it much simpler to tune, and I can't tell any difference as far as drivability or fuel economy goes. All right, 3200 at 95 kPa, all the way up to 64. And I'll go ahead and include the 90 and 100 kPa cells that surround it. I'm gonna add 1 unit. And then I actually should have added one to this one also, just to smooth the curve out. Wait a second, we were rich. I need to pull out a unit. Lean it out. And then from 68 and up, I need to add fuel. So on those, we'll add 1 unit. And the main thing with this is you want this graph to make sense. You want it to basically follow your horsepower curve. So I'm going to smooth this curve out a little bit until it makes sense. Okay, we'll upload that back to the computer and go do another rip. The reason I want to spend a lot of time street tuning this combination to target 0.85 lambda is so that way I'm measuring the air-fuel ratio according to my VE chart, and everything is kind of synchronized together. There's another table called power enrichment that basically I can change if I want it to be 12.5 air fuel, 13.0, 12.0, and once I have my VE chart perfectly linearly targeting my targeted lambda based on the power enrichment table, then when I go to the chassis dyno, theoretically it should save me a bunch of time, because I can just tell it, okay, target 0.80 lambda, target 9.0 lambda, or 0.90 lambda, and that way it just saves a bunch of time. So got the tune re-uploaded, go back out, do another couple hits, see how it looks. to race. Freaking love it. Okay, I'm back inside my apartment now. Here I can explain a little better what I was doing with our logs. So this is actually the log where that G8 GT pulled up. And we did some street pulls against him. And basically on this part of the chart right here, this is logging my lambda on my air-fuel ratio sensor. For gasoline, for all fuels, 1 lambda is stoichiometric. And on gasoline, that equals 14.68 to 1 air-fuel ratio. And what I'm trying to target on the street right now is a 0.85 ratio to get my VE curve to match, or to get my power enrichment curve to match my VE table. Anyways, so as we can see, it looks like, we got 55. These are up here. You can select how many counts of data. You can do your max value, your min value, your average, and the last recorded values. So if we look at our counts, we can see that we have really good data up here. We have 330 counts, 600s, 500, 400s. Anything really over 50 is pretty decent. So even on here at 2400, 55 counts of data, only 2400 at 2000. However, it kind of makes sense because it's right next to it's the same value as 2400. So anyways, I trust this data. So what I'm basically looking at is, okay, 0.79, that means I have too much fuel compared to my 0.85 target. Too much, too much, too much. Leans out a little bit, but it's still too rich. Leans out some more, really close, 0.83. And then you can see it goes rich again, and then it goes lean again. So what I'm looking at is this data, and then we'll go to my VE chart, which is in here, in the editor. Bypass the little error message, you're using a beta, I know. Alright, primary VE table. And this is basically the meat and potatoes of your fuel curve if you're running in speed density like I am. If you're not, you're running mass airflow, and it's using a blended value of your mass airflow curve and your VE table. I like things to be simple, and I try to, this is a race car, I don't care about that last 2% of efficiency, so I'm only using VE. Anyway, so let's go back to the editor, or the scanner. Okay, at 2000 RPM, all the way pretty much, okay, so we're 0.79 here, and then it goes down to 0.74. So I'm only going to pull out 1 unit out of these 3, actually I'll do 2 out of those. I'll do 1 unit out of these 2, so 2000 to 2400 at 95 kPa. 2024 at 95, and I'll actually go ahead and do multiple cells that are around it, plus or minus in kPa, because it's generally going to correspond. And I'll add a -1, which will pull out a little bit of fuel. If we go up the graph, it goes 0.77 to 0.74, so I'm going to pull out 2 units. Actually, I'm going to do 3 units on the 7.4 and just 2 on the 7.7. So 3200 at 95. Where are we? Pull out 3 units there, whole bunch, and then just 2 on the previous. And then of course we'll look at it, see if it makes sense. It does. And then I'll adjust the ones that are above it to match on this chart. That way the curve follows your torques and horsepurs. Okay, moving up, we're at 0.78 and even 0.83 above it, so we know both of those need to get leaned out. So 3600 at 95, I'm going to pull out another 2. Actually, I'm going to go back and pull out more out of all these, because I think we're just super rich right now for this manifold. Down low, this engine does not have a very strong torque curve. It is all top end. And so you can even see that in my VE curve. It's pretty mild up through here, and then as soon as it gets close to 5,000 RPM, it jumps up on torque. And then I think we're supposed to be riching it up over here. Yeah, it's a hair lean. All right, so next, moving up, 4,000 RPM, 95. We're still rich, so I'll pull out a unit for all these corresponding cells. Lean her out a little bit. Moving up, 83. So we're pretty close. I'll go ahead and pull 1 out, just to see. So 44 to 48 at 95 as well. Pull one out of you guys. And I know there's ways to take this data log and it will calculate an error percent, and you can use that percent error and multiply it universally across the table, but I don't know how to do that, so I'm doing it this way. And it takes a little longer, but that's okay. And then 6,095 are also 0.82. So I'll pull another unit out of fuel there. Nope. 0.84, that's pretty good. I'm not going to touch that. We'll leave that alone. And then here at 6,800 RPM at the very end, we're going to add a unit at 6,800. And because we have a 7,000 RPM limit on this motor, I like to take that last value of 6,800 and then just copy it over all the way the rest out on the curve. And actually, if we look here, that's okay. So it has a little dip here, as we can see. So we're at 112, 111, 110, back up to 111. So it's pretty safe to say that's probably supposed to be 111, and this one will make 112 also. That way the graph just makes a little bit more sense as it carries out. Right here too, it's a little strange. I'm going to come in here and make these. Actually, we'll do 102, 103, 103, oops, 102, oh my gosh. There. Because everything needs to kind of be linear, and it just needs to make sense. It's pretty simple. This basically needs to represent your horsepower and torque curve. So the motor will come up, it needs a bunch of fuel at peak torque, and then normally, on a normal engine, your peak torque would be somewhere around the 5,000 range, and then it would taper back down. However, with my manifold, my RPM limited has not fallen off yet. Like if we look here on the scanner, so right down here, I'm logging horsepower. Well, I'm logging torque and then multiplying to get horsepower. And if we follow my RPM gauge all the way up to the rev limiter, watch horsepower never quite falls off. So 479, and then it shifts. And that number can't really be used to be compared against anything else other than itself, just because it's a calculated number. But anyways, so yeah, that's basically what I was doing while tuning. Next stop, we're going to go on the engine dyno, or the chassis dyno, not engine dyno, and actually figure out, does this motor want 0.85 lambda? Does it want 0.80 lambda? Does it actually want 26 degrees of timing throughout the curve? Does it want 27? And so right now this is all just my speculation of what I think it wants, but we won't actually know until we get on the chassis dyno. So thanks for watching, and I'll see you guys later.